and it's got a lot to answer for. It has saved countless lives, but it's done more than that, because in 1871 it shone a light as clear as day on the future. Souter stands between the Tyne and the Wear. Sunderland on the Wear and Newcastle on the Tyne were both very busy ports in the 1860s. Happy days. But there was a problem. As many as 20 ships a year were lost on the notorious Marsden Rocks. Something had to be done. A lighthouse was clearly the answer. But the lighthouses at the time weren't very effective. They helped, but they weren't brilliant. Excuse the pun.
Lighthouses were traditionally lit by oil lamps, but these were a poor source of illumination, often difficult to see from the deck of a ship. So in order to make lighthouses brighter, you needed a new source of power.
Electricity seems obvious to us, but 140 years ago people were still dependent on candles and gas lamps to light their homes.
For centuries, electricity had fascinated scientists and been used as a form of public amusement. It wasn't until pioneering experiments were carried out here at the Royal Institution that its true potential began to emerge.
Michael Faraday, the father of electricity. One of the greatest scientists ever. He must have been. He was on the old £20 note. He conducted most of his experiments into magnetism and electricity here at the Royal Institution, and his practical demonstrations to a distinguished audience of fellow scientists and enthusiastic VIPs were the talk of the town.
On the 17th of October 1831, in his laboratory at the Royal Institution, Faraday made an amazing discovery using simply a magnet and a wire coil.
When you agitate the magnet within the coil, you can either rotate it or, in this instance, move it up and down. The lines of force in the magnet are cutting the wires. This, as you can see by these lights being illuminated, is generating electricity. Nowadays we'd say that we were exciting the electrons, but of course at that point Faraday didn't know that. What he did know was by doing this he was generating electricity. And the bigger the magnet you used and the more coils you had, the more current you could generate.
But Faraday was a man of theory and experiment, uninterested in the world outside his lab.
Square-toed Cuban heel. Nice one, Mike. Electricity was confined to the laboratory. It was a scientific curiosity. What it needed to become a powerful technology was a practical application. Enter an engineer, Frederick Hale Holmes. He had a brilliant idea.
And here it is. Holmes' high-output generator was the first in the world to be put to practical use. It was made of a series of discs with U-shaped magnets set round the edge. In between the discs, he set the wire coils. When the discs were rotated, a current was induced in the coil. Power is all very well, but it needed a purpose, and Holmes found it in the form of carbon arc lamps. This is the lecture theatre at the Royal Institution, and it was here that an amazing experiment was demonstrated by Faraday's great mentor under the enthralled gaze of society's finest.
The principle of the carbon arc lamp had been discovered in 1802 by a chemistry professor, Sir Humphrey Davy. In his experiment, he connected two carbon rods via wires to a primitive battery. He found that if he moved the rods apart, a spark crossed the gap between. It was the most brilliant light, apart from the sun, that anybody had ever seen. Holmes came up with a fantastic conjunction. He thought he could use his generator to power a carbon arc light to provide the brightest possible illumination in a lighthouse.
It was a major breakthrough. In 1857, Holmes sent his proposal to Trinity House, governors of the lighthouses of England and Wales. Following trials supervised by none other than Michael Faraday, his generator and arc lamp were given the go-ahead and installed at Souter in 1871.
This is very much the business end of the lighthouse. Here is where the carbon arc lamp would have been placed. Fortunately now it's an electric bulb. Boo hiss. This arrangement is called the diopter. What all these prisms do is concentrate the power of the arc lamp 230 times, which meant it had an astonishing 700,000 candle power. The other marvellous thing about it, of course, is that it moves.
This lighthouse was the most technologically advanced in the world, transforming the lives of those at sea. One American observer noted that it cast shadows on the deck of his boat.
The light was so bright, the lighthouse keepers had to wear these dark glasses to check on the carbon rods. The problem was that carbon arc lamps are brilliant for lighthouses, but not very good for your front room.